Dankie Manette. Good afternoon, everyone. So yeah, my title for my master's is the development of an IPM system for sucking insects in South African decision fruit orchards. So for my master's, I focus on two sucking insects. Today we're just going to look at Cenaeus carnifex, commonly known as the bedbug. The main area of concern was in the lung kloof, and reports of damage was up to 50%. As you can see in those images, look how it sits on that pack and pair. So the problem was there was damage reports. We didn't know what caused the damage. We walked in the orchard, we saw the redbug feeding on the fruit, but the farmer said it can't be. They've seen the redbug for 50 years in the orchards, it can't be. So I did inclusion-exclusion tests on the fruit with the redbug. But in the same breath, I had to test for apple stem pitting virus because the damage looks very similar to the damage we found in the orchards. So how it worked is I had, for my inclusion, I had bags put around the fruit. I had fruit set for the exclusion. There was no insects in the bag. And in the first inclusion, I put 2 insects in, closed the bag. The next one was a month later. I opened the second inclusion bag, added insects, and a month later again added bigger fruit. The fruit was harvested and evaluated externally and internally. So as you can see, this was at a tree that was positive for apple stem pitting virus. Look at the fruit that was in the exclusion bag with no insect in. It was clean, no external damage, no internal damage. But as soon as you look at the inclusion fruit, you can see the craters on the external and the corky layers on the internal, on all 3 inclusions. Just to show, this was a tree that was negative for apple stem pitting virus, and the damage looked the same. The exclusion are clean, and the inclusion fruit shows damage. So we know the redbug causes damage, but we are losing active ingredients and chemicals, so we had to look at alternative biocontrol products. So I tested some EPFs for biocontrol. I tested 3 commercially available EPFs, 1 native EPF or isolate that was found in, or is in Stellenbosch. So I tested 2 Bavaria bassianus, 2 Metarhizium species, and I made then a constant concentration solution where I dipped the insects in, placed it in a bioassay chamber that consisted of a 2-liter ice cream tub with sand or stabilized sand and a stabilized spare, and then I assessed the bioassay chambers for 14 days daily to monitor the mortality. So in that experiment, I repeated the experiment with new inoculum as well as fresh insects. So as you can see in these images, look how the Metarhizium mycosis goes out of the redbug, and the other image is the Bavaria mycosis going out of the redbug. So here is some data. On the y-axis, we have mean mortality. On the x-axis, we have different treatments of EPFs. And it's clear that the purple bar is the winner. This was at day 5. In the batch 1, it had almost 100% mortality, and in batch 2, it had 76% of mortality. So the Metarhizium anasoplei Meta 69 was the winner between the other 3 EPFs as well as the control. In these graphs, we have on the y-axis the survival probability, and on the x-axis time, that's in days. And again, we can see the purple line reached the LT50 value the quickest, as well as 100% mortality was reached the quickest. So we know the redbug causes damage. Under laboratory conditions, we had Meta 69 was the winner for EPF control. What's next? Testing the EPFs under field condition. We all know it's different between lab and under field conditions. Thank you very much.